Good morning, everyone. In the next couple of minutes, I will share with you, I heard throughout the presentations, main topics, how we are moving from prototyping into manufacturing, what does it take to move from prototyping into manufacturing. And in the next couple of minutes, I will try to show you a few applications that we are doing and new materials that we are introducing that will enable our customers to actually take this step forward. And by taking this step forward, what I will try to show you is that customers are ready to take the step. Customers are willing to move forward with additive manufacturing and take us all the way to production. In many cases, the limitations come from us, from the industry. And if we will change our minds and we will change our attitude, customers are ready. Let's start. So this is a case study from a project that we did in China, and let's see that. So what you can see here, it's actually mini car, BMW Mini, and we started a discussion with the customer, with the manufacturer, and they came to us. They tried to do additive manufacturing in the past and introduce, and I think someone yesterday also showed you some parts that were produced by additive, but customers didn't really buy out because the industry, we introduced them. So with our technology, what we actually enabled is we told the customer, just a second, this is additive manufacturing, why don't you, the customer, define the part, design it, right? This is what we do. We can do one of a kind. And BMW Mini bought this idea, and actually when you buy a BMW Mini in China, you can go into their website and you can design your own part and influence the way your car would look like. And then we came up with these kind of ideas that combine the Chinese tradition with the mini culture, and it's amazing what kind of ideas people are bringing. So this is the same polyjet that we were using for prototyping for so many years, and no one actually took the step forward and say, okay, let's go all the way to the customer and let the customer show us what they really want. And once we did and we took this step, all different products came out of it. Obviously, we had a lot of challenges to overcome because that require different post-processing. If you guys know PolyJet, and I guess you do, it has a lot of limitations in terms of UV resistance and so on, and so we had to overcome some technical issues. But once we did it, now customers are asking us for the next thing. They say, oh, just a second, can you do that? This is the fuel cap. Why not go another step forward and let us influence even more? So customers are ready. People want to influence, and it is up to us to let them do that. So it definitely has applications in the industrial world, like we just heard from Benny from Velo. But if we take it all the way to the customer, we say manufacturer to customer, so many beautiful things can come, and we can open for ourselves a whole different range of applications. So basically, if I'm looking at so we did, throughout the years, we had 3 different segments, the manufacturing, tooling, and prototyping, and we are there. The industry, we as an industry, this is where we are. We are looking at really small volume manufacturers. We can do this gear, we can do this, we can very small, we can replace small spare parts. But from what we are seeing, customers want to take us all the way, and customers are waiting for us. So let us see a few things that Stratasys has been doing, and we announced our new materials. So within the Stratasys new products and materials, basically we allow designers to do all the design in one ecosystem, right? So they don't need to go outside from the ecosystem. They can do everything in one under the Stratasys ecosystem, from concept design to final design. And basically, what we allow is a very detailed design, right? So the designers can go in, and as you can see, all the way to the PCB, right? All the way to the PCB, and then the communication models, and when they are talking to their electronic engineering, they are talking to their other department, everything is already really well crafted, and they can communicate their model in a very detailed way. We have a very interesting case study with an automotive company in Korea, and they wanted to design this key. It's a new type of keys, and instead of taking 9 days, it took them 4 hours. And as you can see, it's a very, very detailed design with a new material that we introduced. It's a very ultra clear and interesting, right? You see that it's quite an impressive product. That, by the way, it comes out of the machine like that. It's not post-process, come out of the machine like that. Very interesting. But when we looked at that and we said, just a second, this product, this ultra vero clear, also opened for us a new set of applications out of the prototyping industry, out of the common. So yes, it's a very powerful tool for designers, but can we do something else with it? Can we approach other customers or other niche that we have never touched before? So we started the discussions with artists. So all those beautiful pictures that you see here are arts that artists are doing. They were able to do that by hand, because it doesn't make sense to go into tooling, and in many cases tooling cannot support what the artists really want. And if they want to go all the way into tooling, it would cost them millions of dollars to create the tool. But with additive manufacturing, it's actually doable. It's doable, it makes sense, and all those parts are actually produced by the thousands, right? It's not tens of thousands, produced by the thousands by artists. And the beauty of it, if you can see this dragon egg on the left corner, it's a very famous Chinese movie. The artist had to do them one by hand, so obviously his market is very limited. And we produced for them thousands of those. And each of one of them has its serial number, right? So artists know exactly how much are being produced. Each of them has their serial numbers, and now these items are actually tradables. They have a value. So we can start and see people are trading that. People are bought it in a certain amount because it's just a limited production. Now they're selling it outside. So for the artist, they open a whole new range of products and markets that they have never touched before, right? So again, we took this very nice concept of our new printers, the J850, by the way, we just released 2 days ago, officially announced, and our new material. So we took it all the way from design into products that customers can buy. You and me, we can go on Taobao or any other online platform and buy those products. So customers are there, and definitely there is a lot that we can do around that. Another area where we are making a lot of progress is with our medical applications. Within the medical applications, we hear a lot about transplants, and we hear about prosthesis and so on, but from what we see, those are still limited. One of the key applications that we see in medicals are the surgical guides, communication models, and how we train our doctors, and how doctors getting themselves prepared into surgery. So just recently we announced our digital anatomy printer, which is taking a step forward from our previous surgical models. And the surgical anatomy printer has packages of materials, completely new materials, software, and a different printer. And basically what we are enabling is a full-scale part that the look and feel is exactly like the real part. Exactly like the real part. Until to the point that when the surgeon trains on our product and he needs to do a heart surgery, he needs to apply the same pressure on the knife that he needs to apply on a real tissue. So these days we are working with medical schools, we are working with the biggest medical companies like J&J and Boston Scientific and so on. So for them there are two main challenges, right? So first of all, they need to design the product and they need to test it. They have all different types of testing areas like pig animal farms and so on. Basically they don't need that anymore. They can just take the part, scan it, print it, and now they can let surgeons actually use it. And the second thing is that when a surgeon needs to plan for surgery, we hear so many cases of surgeons that need to plan for surgery, and I will show you a very interesting video and explain. So what you see here is actually a real scenario of a TAVI surgery. TAVI surgery is where you replace a valve in the heart. I learned so many medical terms in the last couple of months when we are looking into this industry. So in the past, when a doctor needs to do such kind of surgery, it was a very complicated and very life-risking surgery. It's an open heart surgery. They need to, I will spare you with the details. But what you can see here is that basically they printed, so they took the MRI data, they printed exactly the same structure of the heart that where they need to produce or where they need to operate, and they let the doctors train before they go into surgery. The margin of error for this kind of surgery is 1 millimeter. 1 millimeter, this is the margin. So if the doctor make a mistake and touches 1 millimeter, it's a failure and a deadly and a fatal result. But if they do that right, instead of taking 3 months of recovery, it's 3 days of recovery. And the surgery and the success rate goes up from 70% to 97%, right? So with those communication models and where we enable doctors to actually practice before they go, but not just practice as something that look like maybe it's the actual thing, this is a real case from a hospital in Xi'an where there is a phenomenal doctor that is doing those kind of things, and actually very inspiring. So I like those kind of applications because, first of all, it saves life, actually saves life. Two, as an industry, if you look at that from a commercial point of view, each one of them is different. Each patient is different. My properties are different from any one of yours. And if each of us needs to go and do that, each patient is another part that we need to produce. And this is the power of additive manufacturing, that each one can be different. Each one is different. It's not the same gear, but each one of us, the disease look a little bit different. It may be the same type, but looks a little bit different. And by allowing this process, capturing the data, analyzing and slicing it, and then printing and giving the doctors the real model, we actually save life, each and every different patient. Another area where we make a lot of progress is on spines, right? Again, spine, there is no way to train on how to do a spine surgery unless you are using a pig lab or you use cadavers and so on. They just don't have a tool so we are working, this one is from J&J, they don't have a way to train their doctors. They have similar things, it looks more or less the same, and then at the end of the day they have to take the doctors into cadavers lab and train them. And this is first of all, very painful process. It costs them a lot of money. Eventually the doctors don't, so it's and a limited resource, right? And governments around the world are trying to reduce the number of cadavers, and it becomes a very painful process. With what we have with the digital anatomy printer that we have, it is actually the same. It's actually the same. When you need to drill, and you have to drill exactly the same that you drill on a real bone. When you have to cut, you are cutting exactly like you will cut on a real spine. And it is just another step of the way we train doctors, and we give the doctors hands-on experience, which they didn't have before, or they had a much limited one, right? So you just, and another very important part is that we can take real IP, right? Real patient's IP, and convert it into a model and train on the model. Because let's say you need to train on certain disease, it's really difficult to find the cadaver that has the exact disease that you need to train on. But once you scan it, I can just send you the data file, you can print it, and there is no limitations of how many times you can train on this procedure. This procedure actually, the difference of error is again about 1 millimeter, and the difference is paralyzed or walking. Paralyzed or walking. 1 millimeter paralyzed or walking, and this is another real case that we are doing. This one is in India, where they actually printed the part, trained for the surgery, and it was a very successful one, right? So again, taking the additive manufacturing one step forward into production, but what I'm trying to show you here is that number of applications is much further than what we as the industry talking about, right? We're always talking about the same kind of applications, marine, aerospace, and I will talk about those in a second because obviously Stratasys is there as well, but what I'm trying to inspire you with is when you talk to your customer, listen to what they really want. Listen to what they really need, and then you will find out that your technology is there. It's just us removing the barriers of what we can do. This is another very interesting case from Medtronic. They developed a new tool to deal with the blood vessels, and they just could not find the way to train and to introduce very complicated disease on the blood vessels. So if you want a standard blood vessel, no problem. You can buy off the shelf, made out of silicone, very nice. But that doesn't actually show you how to solve or how to cure the disease that you build a tool for. So they printed the blood vessels, they can plant inside exactly the disease, and let the doctors train on a real model, and let the doctors repeat the process again and again and again until they are perfect. What we learned is that instead of a surgery that takes 5 hours, it takes the surgeons to do the surgery only 4 hours. So let's take it again, very nice for the patient and so on, but here we are also commercial companies. Let's see from commercial point of view, the doctors or the hospitals still get the same amount of money for the surgery, whether it takes 4 hours or 5 hours. If we can reduce from 5 to 4, they can perform another surgery a day. It's a 20% increase for the hospital revenues, right? So it's a very nice application, saves lives, but also has very clear commercial impact on our customers. Let's talk a little bit about our second technology, or the FDM. So obviously we're making a lot of progress also with the FDM, and with the FDM we're actually breaking barriers. What you can see here, it's actually a part that flies in space. So NASA's satellite has an FDM part that they did all the qualifications and they did all the processes, and they qualified it, and it flies in space. We like this kind of products, and we like those kind of applications because I think it shows that the products that we can enable our customers to do basically covers the challenges, right? If it can fly in space, it definitely have applications also in Earth. And it's up to us to work with the customer. We cannot expect the customer to come to us and say, listen, this is what I need, and I want to do that with this material, and this is the geometry that I need, and that is how much I'm willing to pay. This is a dream customer. Most of the time, they are not like that. It's our responsibility to walk into the customer side and see and tell them, let's see what we can offer you and how we can help you to improve your design. So in this case, we completely changed the design, converted the process, converted the part, and we reduced the weight in such a way that they actually changed the configuration of the satellite, enabling more throughput than because the ratio was much, much better. So again, it's up to us as an industry to walk in and explain to the customer that it's not enough, okay, I will give you this one, just scan it and print me the same part. It would not work, because then there is no value. The value comes where we take the part, we completely change the design, make it suitable for additive with the right materials, then customers can start and see the real value. So there is a new materials that we are introducing into the shop floor that with those materials that the wear and tear, the features are so good, it's actually sustained same as metal parts. And what we are enabling the customers to do is we are walking into the customer, into the shop floor, mostly in automotive or in manufacturing and so on, and we take the part that they have, we completely redesign it, we apply the right materials, and these kind of parts produced by the thousands. Because the customer says, oh, just a second, this was a part that was weighing 10 kilos in this case, and I needed 2 employees to carry that. They didn't really like to do it, and if the shift manager is not that, they are not using, because it's too heavy, and it also has some risks involved. It's in an automotive manufacturer, and if the shift manager they are not using, and now we convert it to be a less than 1 kilo, very easy to use. So employees are happy to use it. And we have so many different applications like that that came out of the customers and what, say, for example, one case that I didn't show here is that with the car manufacturers, we produce to them a combination of materials that, like a very, like a glove that they can wear, that on one hand is rigid enough, so if an employee actually hit his finger, it's not broken, but it's flexible enough that they can do their job. And this is something that we actually walk into the floor, into the shop floor, and we saw an employee that is wounded. So what happened? He banged his finger. So let's see how we can help you solve that. Let's see what we can do. We went into engineering process and we manufactured those. If you would go to BMW Shenyang in North China, you would see that all the employees on the manufacturing line, they have their own 3D printed glove, right? It's a 3D printed glove. My hand is definitely different than yours. Each one is different. So what we do, we scan each employee and we manufacture per the employee. This is the power of additive manufacturing, that each one is different. So this is this part. And what I'm trying to, and I hope that this message is the message that I'm giving you, is those materials, those new materials, enable us to stretch our reach to the customers and actually break, we call it the jail of the prototyping, right? We are in kind of jail of prototyping, of very limited manufacturing. What the new material and processes enable us to do is actually break it. And from my point of view, it's up to us. Customers are ready. It's our language, our approach to the market that needs to be changed. Last but not least, I think that we as an industry have responsibility to source our materials and take and be much more sustainable. I chose to show you this picture because I'm very passionate about oceans, very passionate about saving the ocean. But again, from commercial point of view, this fishing net is actually made out of ABS. All of us in this room is doing any type of polymers. We are printing ABS. So why not take those kind of things and resource and take those fish nets and recycle them and use them again and again and again for our product. So we took this approach, and we actually started to work with a very interesting company in China, led by a very interesting young lady that actually sits here. And she started giving us those ideas how we can take this ABS. Those resources are there, they are almost free. And by resourcing those fish nets back and use them again and again, we do two things. We actually reduce the cost of our raw materials, we save the planet, and I think it's our responsibility to actually, to look at things in a much broader way and see how we can limit our impact on the planet. I was happy to hear other speakers talking about the same concept as well, right? We're talking about those 3 Ps, people, planet, profit. We have to work on those 3. And I believe that this is, again, our responsibility as an industry leader to take it. So we are now sourcing some materials from Remake Hub. We are testing to see how we can implement those recycled materials into our product line. Thank you very much. I will be later happy to answer more questions. I hope I gave you some other topics to think of. Thank you very much.